Hello friends, welcome to the Society YouTube channel. In this session I am going to discuss about the very important name reactions named as Mannich reaction. First of all, what is Mannich reactions? The reaction involves the condensation of a compound containing at least one active hydrogen atom, formaldehyde and ammonia, or 1 degree or 2 degree amine in the form of its salt like NH4Cl. The compound formed in this reaction is known as Mannich base. The catalyst is an acid or base. So let's start to write the examples of Mannich reactions. For examples, we have R C double bond O CH3 and CH2 double bond O. This is the ketone and this is the formaldehyde treated with ammonium salt NH4Cl. In NH4Cl, the ammonium and is positive and Cl chloride is negative. In presence of base or acid, so either we take base or acid. H plus represent for acid but OH negative represent for base. After reaction we get R C double bond O CH3 and CH2 NH2 CH2 NH2 and HCl also, and this product is known as Mannich base. So we can write here this is the Mannich base, and now we will take another example. Now let us consider another examples of Mannich reactions. In these reactions we will take C6H5 C double bond O CH3 and formaldehyde HCHO and treated with CH3 whole twice and H4 not NH4. Here 2 methyl group is connected with nitrogen, so here is 2 hydrogen atom with positive charges and Cl minus ion. Here reaction take place and get C6H5 C C and C double bond O and here C2 H4, that is CH2 single bond CH2 and NH present here, nitrogen contain positive charge and CH3 whole twice Cl minus and 1 mole of water. This is the Mannich reactions. And here note that aryl amine do not give these reactions, and the amines may be primary or secondary, but the most convenient are secondary amines since they possess only one replaceable hydrogen atom. The product with 1 degree amine is 2 degree amine Mannich base, which further reacts to give a 3 degree amine. And let us consider the mechanism of Mannich reactions. Before starting the mechanism, here we will discuss about very important point, that is aryl amines do not give aryl amines do not give this reaction. That means Mannich reactions. Let us consider the mechanism of Mannich reactions. There are two types of mechanism. First, acid catalyzed and second, base catalyzed mechanism. So first we will discuss about acid catalyzed mechanism of Mannich reactions. First is acid catalyzed mechanism. In acid catalyzed mechanism, first we will take keto molecule, that is R single bond C double bond O and CH3. This is the ketone, and the ketone molecule tautomerizes to form enol form, which is known as, and this isomerism is known as keto enol tautomerism, because keto molecule transform into enol like this, and here double bond. This is the enol, and this isomerism is known as keto-enol tautomerism, because the hydrogen of carbon atom moves toward the oxygen and double bond moves carbon carbon atom. And now we have formaldehyde. So formaldehyde H C double bond O H react with amine, that is R2NH. This is the secondary amine, and gives hydrogen carbon, hydrogen and oxygen. The carbonyl group change to O negative, and this is carbocation. So here OH and NR2, and this product perform hydrolysis, not hydrolysis, in acidic medium, dehydrated in acidic medium. Here acid as a catalyst, because this is the acid catalyzed mechanism. So here we will take acid and dehydrated due to removal of H2O molecule gets converted into CH2 double bond NR2. Nitrogen having one lone pair of electron, and now the pi electron of carbon and nitrogen moves over nitrogen atom, because nitrogen is more electronegative than the carbon, and in presence of enol, that is CH2, not CH3, we will take enol CH2 double bond C OH and one alkyl group. This is the enol, and the pi electron of carbon and carbon moves toward the outside carbon, and we get R single bond carbon having hydroxyl group OH, and carbon gets positive, that is carbocation, and here CH2 single bond CH2 and bonded with Nr2. Now due to removal of one proton, from hydroxyl group removes and bond moves toward oxygen and carbon, then we get a final product of Mannich reaction, that is Mannich base or C double bond O and CH2 CH2Nr2. This is the Mannich base after removal of one proton, and this is the Mannich base. Mannich base, and this is the mechanism, acid catalyzed mechanism. And now further I am going to study about base catalyzed mechanism. So let us consider base catalyzed mechanism of Mannich reaction. In the base catalyzed Mannich reaction mechanism, first we will take ketone, that is RCO CH3, alkyl group CO CH3, this is the ketone, and treated with sodium ethoxide base C2H5ONa, this is the sodium ethoxide base, and then we get a carbanion ion and ethyl alcohol, that is RCOCH2 having negative charge, this is the carbanion, and ethyl alcohol C2H5OH. So we can write here carbanion, and now the carbanion form, and then the formaldehyde molecule react with secondary amine, so hydrogen bonded with carbon having carbonyl group CO, this is the formaldehyde, and react with secondary amine HNR2 dialkylamine, and we know that clearly the carbonyl group in which the pi electron between the carbon moves toward oxygen due to more electronegative, and oxygen gives negative and carbon gives positive. And also we know that the nitrogen have one lone pair of electron which is act as a base, so it goes toward carbocation, and hydrogen goes oxygen O negative, and then we get H single bond carbon and single bond OH, and here hydrogen, and here Nr2. And now the form molecule react with CH2COR, that is the carbanion. So it reacts with carbanion. So carbanion CH2 having lone pair negative charge, and C double bond O R and the negative charge of carbocation. In this molecule, the bond moves toward oxygen, then carbon gets positive, and due to this the carbanion attack over the carbon atom and form R2 NCH2 single bond CH2 COR. This is the final product of the base catalyzed mechanism of Mannich reactions. Most favorable mechanism is acid catalyzed. Note, with unsymmetrical ketones, more highly alkylated alpha carbon is substituted by the amino methyl group. So let's another examples, very important. Note, with unsymmetrical ketone highly alkylated alpha carbon is substituted by amino methyl group. So let us the examples. CH3 CH3 C double bond O and CH bonded with 2 alkyl group CH3 and react with formaldehyde HCHO and secondary amine, that is R2NH, and the product is CH3 CO C and CH3 whole twice CH2 Nr2. This is the second case of Mannich reactions. And we have another examples also, and this case is something different to them. In this case we will take succinyldialdehyde, that is CHO CH2 again CH2 and CHO. This is the succinyldialdehyde, and succinyldialdehyde react with primary amine CH3 NH2. This is the methylamine as well as acetone. The chemical formula is CH3 single bond CO single bond CH3. This is the acetone, and product will be tropinone. The structure are like this. Tropinone, this is the tropinone. Here nitrogen and one methyl group CH3, and this carbon have oxygen, that is carbonyl group. This is the product named as tropinone. So this is the overall Mannich reactions with two examples and two another examples and two types of mechanism. First is acid catalyzed mechanism and second is base catalyzed mechanism.